setting up a connection manager, chain state manager, and we are basically here creating a node, and we are creating here, you can see that we are creating random messages, basically. So our harness will receive some a buffer from the fuzzer, and we'll convert this buffer in a message and test our application. So that's what we do here. So here you can see that we are basically creating a random message. And then we will test how our node deals with that message, right? And it runs, for example, thousands of iterations per second. So it's a lot of inputs, a lot of test case. We are creating a lot of random messages to know exactly if there is a kind of message, a kind of data that can make, for example, our node crashes or can review a memory issue. And right, that's it. This is basically fuzzy. Um, any question? Okay, it's okay.
How random are the messages that the user creates? Like we can see how a vector from the user looks like.
Sorry, I didn't understand your question.
Like you are generating, you are consuming random with consume random length byte vector. You are
Yes,
generating messages from a random stream of data or something like that.
yes.
But how is that it produce valid like messages or things that the consumer of those messages can process?
Yeah, I don't
Like
know. I don't know if it's creating a valid message. We expect it because when we run fuzzing, for example, um, at the beginning, it will create a lot of random stuff. But after some hours, you see that the fuzzer is creating like a lot of valid messages, right? Because the fuzzer doesn't know how to create a valid message. It's like you run a bytes. But remember that we are using, you can use, for example, a coverage guided fuzzy. So uh, random messages won't reach any interesting code, for example. But valid messages will reach interesting part of the code, right? So when you start fuzzing at the beginning, it will create a lot of random stuff. But after some hours or after some days, you will note that it will only working, only playing with valid messages. There are there is a logic behind how a fuzzer works, how it creates messages, how it mutates messages, how it generates. But yeah, I want to play this in that. But basically, we have, for example, lead fuzzer. Lead fuzzer is a tool that
Okay.
lead fuzzer will send the buffer here, and
Mhm.
we will play with this buffer, right? But lead fuzzer knows our code because of instrumentation, right? So lead fuzzer will send a buffer here, you send a random data here, and then the lead fuzzer, for example, or any other fuzzer can know if that input they provided reaches a new piece of code or not, right? So, for
Okay,
example,
so the library knows how to set the boundaries of the message.
yeah, basically,
Okay.
because for example, they will send us a buffer here, then they will see like, oh my god, it didn't reach any important code, so I can discard. or I can mutate. So let me try to mutate. Then they mutate or create a new data in the buffer and then send back to us again. Then, oh, it seems I created a valid block message. Interesting. So save that. Then
Okay.
the further you get that valid message and that interesting input, you create mutations. You mutate that, right, to find new interesting inputs. So the way the fuzzer uh, mutates and creates new inputs is based on code coverage, right? So
Yeah.
this is basically how a coverage guided fuzzing works.
Okay. Thanks.
Thank you. Okay, so for example, uh, what kind of architecture Bitcoin Core code has? I understand that it's very modularized, right? More or less, more or less. I wouldn't say that we have a strong architecture, that we have everything modularized. We have some classes that do specific things, but the code itself, I usually say that's accomplated, right? But we have some projects to make the code better. We have, for example, Bitcoin kernel that wants to modularize some consensus stuff, right? To create a lead for these. We basically have a kernel. But in general, I wouldn't say the code is, for example, very well modularized, and we have a, a well specified, for example, architecture. I wouldn't say that. Some things in Bitcoin Core need refactors, but refactors are hard to deal in an open source code. Do you know why? Refactors are good, but at the same time they they are bad. Why? In open source project like Bitcoin Core, for example, why? You know, you have an idea. For example, why should we avoid refactors, for example, in an open source project? Andy said because of the if it works, don't touch it. Um, no, I wouldn't say this is the strongest reason because if we have unit tests, fuzzy functional tests, and a strong testing uh, stuff, I would say that okay, we can touch the code because we have tests for that. But yes, it's a reason. If it works, why should I touch it? But any other reason? Try to think about refactors and the open source world. Because it's a problem for sharing different parts of the code. Yeah, basically because we can have a lot of conflicts. So it's an open source project. We have a lot of people working on the same code. So sometimes I'm working on an important feature, but if someone refactors that code, I would have to spend a lot of time trying to fix my my change because I had to rebase, and rebase takes a lot of time. It's not cool and easy. So yeah, so that's why we usually avoid refactors. When refactors are well done, in my opinion, for example, I am creating a new feature, I am touching that code. Okay, I can refactor that part of code because I'm already touching that. But for example, creating pull requests just with a refactor, for example, yeah, it's hard to say that. Yeah, because we have a lot of other pull requests. Sometimes, for example, three people reviewed a PR, but someone did a refactor, then the PR author has to rebase the PR, and everyone has to review that again because it's a change. So yeah, so that's why we usually avoid refactors. But it's because it's an open source project and it's hard to deal with that. Are there any levels of abstraction in the architecture? I don't think we have well-defined abstraction. Well, you can see the Bitcoin Core Bot Academy. This is very good website. Let me share with you all. Um, because here you can see, for example, the architecture, but you can see, for example, the threads, the library structure, search for organization, and I didn't talk so much about that because it would spend a lot of time, and it's not cool to speak for hours here. Okay, so I shared the link here in the chat. Um, any question now? I think we can open for questions. I said a lot of things. I know it's hard to process like a lot of information, but my goal here is basically give you an overview of the Bitcoin Core, and I'd like to to talk about contributions now. So let me share my other screen here. Stop presenting. Looks like. So how can you contribute, or how can you start contributing? Um, how would you start? That's the question. So, for example, Bruno, I will start contributing to Bitcoin Core. I'm asking you, how would you start, for example? Oh, um, what is a good way to start contributing to Bitcoin Core, for example, in your opinion? Yeah, you can you all can say more.
Doing PRs, reviewing PRs.
Reviewing PRs, yeah. Any other? Christian asked if Bitcoin Core GUI is a separate project. It's part of Bitcoin Core, but at the same time is basically separated because we have in the GitHub is different. It's other repository. So yeah, it's separated. Um, Johnny said test. Okay, test is important. So review PRs, test, any other? So I brought here, for example, three ways that you can start. First, code review, not only code review, but PR review is really important because uh, I know it's it's nice to create a new feature. It's nice to open a PR, but we need people reviewing. We need reviewers because we have a lot of open PRs waiting for review. So you can open a lot of PRs. They will stay there for a long time because we don't have enough people reviewing, in my opinion. So like, okay, reviewing is very important. So sometimes people think, I think writing an issue, writing a feature is more important. No, code review is very important. And if we don't want bugs in our code review is very important for that, right? So code review, PR review, and this is a nice way to learn about protocol and to learn about the code base. Good first issues, good first wishes. So we had some good first wishes. The name is like the name is it's obvious here. So good first issues. We have a lot of them. So you can start by trying to solve one of these issues and test improvements. It's also important because uh, we need, for example, more code coverage. So, for example, wallet has few code coverage. It's important. We need more. We need to put wallets, for example. So this is a good way to start as well. But code review, PR review, you can see the good first issues, and start you can start with the tests because it's also a good way to learn about the code base and to learn about the feature itself. Like right. So this is the three ways I think you can start, and we can see a PR together now. What do you think? We have time?
Yeah, let's go. If you have time, great.
Okay, so just to show you that you can learn by reading, for example, by reading a PR, by reading PR code. Anyway, so let me share here. Presenting. Okay, so can you hear my screen? I gave a
Yes.
zoom. I think I zoom. Better? Yeah. So here we have, for example, this PR adds support for raw nodes and raw leaf under TR descriptor discussed in this and this. Okay, so this is a PR, of course. So it's basically implementing a raw node and raw leaf under TR descriptor. So what is descriptor? What is the output script descriptor? Do you know?
Don't be shy. If someone wants to ask or answer in Spanish,
Yeah,
I can translate. Don't worry.
yeah. So basically, for example, I open this PR, you open this PR, then you see, okay, this PR adds support for Renault and Wally under TR descriptor discussed in blah, blah, and blah, blah, blah. Okay, the first part is understanding what is a descriptor or what is a output script. What are output script descriptors, right? The first part is that. So, okay, so basically, output script descriptors are strings that contain all the information necessary to allow a wallet or other program to track payments made to or spent from a particular script or set of related scripts. So, okay, we have, for example, here this definition. I, I sent you all the link. So the first part here is basically understanding what is output script descriptors. Then you can understand, for example, what is taproot. What is taproot? Okay, then you can understand what's taproot. And here is implementing PR partial descriptors. Okay, so supposing you know descriptors, now you have to understand partial descriptors. Okay, you can study that. What is partial descriptors? Then you study taproot. Then, so I'm just showing you that reviewing a PR, you can learn a lot of stuff. Because to be able to review this PR, you need to understand other concepts before. So descriptors, taproot, partial descriptors, then um, here we have the code. So you can see that Bruno inside here specify tree or branch Merkle root in X encoding. Cool. If you study that root, you understand what is a Merkle root in this context, right? Just just to clarify. And here he's implementing this one, specify raw leaf script and leaf version in X encoded. Okay, so if you study the scripter, if you study taproot, and if you know about myrtle root and other concepts here, you can understand what he's doing here, right? Then you can read the code and try to understand the code. And okay, you need some C++, you need to understand C++. This is obvious because sometimes sometimes you can review PR without understanding the context of that change, but you can see like, oh my god, this is a C++ stuff. This thing is wrong. According to C++, you can use that or these functions, for example. So yeah, and right. So here we have the code, and what is important because he modified the documentation, right? So he implemented run node and run it. So he um, improved the documentation, specifying them. But if you take a look here, you see that he touched descriptor.c++ from source script, test, and test functional. So he basically wrote a new feature and added unit tests. So here you can see unit tests and functional tests in Python. So yeah, so it's just an overview that how you can learn by reading code, learning by trying to understand what is doing here, right? Okay, so that's all that I have to bring to you all. So if you have any questions, please do, and we can talk a little bit more.
Excellent, Bruno. Thanks a lot. Uh, come
Thank
on,
you.
if come on, guys. Again, don't be shy. Ask your questions. There are no dumb questions, just dumb people asking. So don't worry. Uh, and
Um, I got a question.
go.
Um, on here in the presentation, you say that protocols don't have a specification. So do you think that the lack of a specification affect the base code of the system code? That's a great question because you said, for example, um, we don't have a strong specification, so it's hard to define tests, right? So how can I write a test if I don't have a specification? Of course, we have specifications like we have beeps and we have some documents, but what I mean that we don't have a strong specification like, for example, like network that we have codes, right? So that's what I mean. But yes, the lack of specification makes writing tests harder. True. And also, I have a project called Bitcoin Fuzz. I basically I do differential fuzzing between Bitcoin implementations. So I showed you fuzzing, for example, but what I do is differential fuzzing. What is differential fuzzing? I have the application A and the application B. Um, So I basically it basically gives the same inputs, the same test case for both applications, and then we compare the outputs, right? So for example, we have BCD and Bitcoin Core, BCD in Golang, Bitcoin Core in C++. But for example, if I give a script for Bitcoin Core and for BCD, I expected both to produce same output. Like, for example, this script is valid or not valid. So I give this script for Bitcoin Core and for BitCD, and then they say this is valid. No, this is not valid. Something's wrong, right? So I have a project that basically does it, and Yeah.
Bruno, sorry. We're gonna keep going with the questions, but I'm gonna end up the streaming so everybody feels free and safe to do their questions, or if they want to open their cameras too. So thanks everyone. I know we have some issues at the beginning with the audio, but later it was fixed. So hopefully we can fix the final recording of this. So thanks everyone for being there, and we expect you to sign up for the next B4OS cohort next year, and keep following us on our different medias, on social medias, and let us know what you think about this. So thanks all.
Thank you.